Well, let me do a quick introduction. As I mentioned in our last class period, we have a wonderful guest speaker today. Don't be modest. This is Mark Summers. He is from CSRA, an application development manager. Is that your role there? So he has agreed to come talk to us because we're introducing the subject of normalization today. And so he's going to give you some examples of real-world scenarios where he has encountered it. So feel free to ask questions, and I'm going to open the floor to you. Thank you for coming.
Thank you. Well, hello everybody. This is class participation time, so I know we just ate lunch and everything, but so is this your first database class?
Yes.
So we all know how to spell it now. How much further have we gotten besides spelling it? What have y'all done? You can talk, it's okay.
Access, tables, queries.
Tables, queries.
ERD diagrams.
ERD diagrams, all right, cool. Yeah, we like to paste those on the walls, and wallpaper our offices with them and stuff like that, so, yeah. Especially you get the big ones, they can take up a lot of wall space, so. Cool. Well, let me introduce a little bit about me. My name's Mark Summers. I'm, like she said, from CSRA up in Bossier City, Louisiana. We've been there for a couple of years now, but we just are starting to move into our new building, so you might see us on the news or something. There's a lot of hype over us moving into our new cool building because it's cool and very, I wouldn't say necessarily like Google-ish or Facebook-ish, but it's modern, you know, and it's kind of geared toward people your age instead of my age. I was used to the old cubes where we didn't look at anybody and have to talk to anybody, and now it's more open, and you can talk to people and all that stuff. We've got what we call a living room where it's just all kinds of funky IKEA-looking furniture and all kinds of stuff, so it's a cool place. So sometime you're up there, pay us a visit. We've got a few of your students working in my group. I'm up to 3. I have about 50 people, and I'm up to 3 from Northwestern, I believe, at the moment. So Quentin Hilaire is how he says his last name, just came up recently, did track here and stuff from the CIS department. So anyway, so cool. So a little bit about me. I'm from Georgia, well, Tennessee originally, and then Georgia. Worked for a big company called McKesson. You probably never heard of them, but they're the largest pharmaceutical supplier in the country. So they supply hospitals with supplies. They also supply drugs to hospitals and stuff like that. They do all kinds of software, all kinds. They're a Fortune 5 company, so they're big. And I worked on 2 systems for them. I worked on a claims processing system. So when you go to the doctor and they say, well, we'll file your claim, come on in. They say, we'll file your claim. That claim, if they were using our software, would come in, get scanned in, put into our system, and what's called adjudicated. So that's a fancy legal term for just basically, what are we going to pay? Maybe nothing, maybe something, whatever, but we go through all the rigmarole and we print out a nice EOB and send to you, and those things you get from the doctor that you can't read, saying here's what we paid. We do that kind of stuff. So that's one system. Database on that one was in Sybase when I started there. Sybase, a little history, was they've been around quite a while. They were Unix-based at first. Them and Microsoft actually partnered in the 90s, and Microsoft SQL Server is built on top of Sybase's database engine. Now, since then, SQL Server has just gone, you know, off on their own. The partnership didn't last long. It was kind of a weird partnership anyway, but they did get Sybase's database engine out of it. So SQL Server and Sybase are very similar. If you ever get to use Sybase and you've used SQL Server, you'll notice, hey, this looks about the same, because it is. So I worked on Sybase. Sybase also had a Windows version, worked on that. Then I moved to they spun off our group, went to a different claims processing system on top of SQL Server 2000 way back then, which was probably the first really production-worthy SQL Server version. Before that, it was kind of rough. Sybase, Oracle, and DB2 were your main databases back in the early 90s, in the 90s, but then SQL Server 2000 was pretty decent. We could use it for production-worthy stuff. And what you have to think about in production is, will it stay up and run, and it doesn't crash on us, and we can back it up, and we can restore, and do all the things that we have to do with databases. So that was a worthy one. Then I moved back over to the pharmacy product, which was, if you're at the hospital and get drugs, there's a pharmacy usually located down in the basement. They have no windows. They only have one way in and out because they've got narcotics and all kinds of stuff down there. And actually nuclear stuff, because nuclear medicine, they've got isotopes and stuff, so it's highly restricted space. But we made a pharmacy application for hospitals. So I would tell people, what do you do for a living? I do drugs. Yeah, that's what I do. So I peddle drugs. So did an application for them. It was on Oracle. We were at 10G and 11G, and the G in Oracle, if you know anything about Oracle. If you don't, Oracle's a big database platform. Oracle and DB2 usually go head to head for how much market share they have. But the G stood for grid, so you could throw more servers at a problem and carry your load that way. This was kind of before the cloud had come into being and was useful, so it was a nice way to take a big database system, and when you start having performance problems, you just threw another Linux server at it and it shared the load. So it was pretty cool technology. Howbeit, Oracle is very, probably one of the tougher ones to administer as a DBA. So it takes there's a dark science, one of those dark sciences to Oracle. You have to get in a room with candles and stuff, and dolls and pins and all that stuff. It's just, it's crazy what you have to do with Oracle. But it's Oracle DBAs make good money because they have to. They have to know some stuff. So let's see what else we do. And then after that, I pretty much got out of the database world per se and went more into the middle tier and front end development. Did a lot of stuff in that. So that's a little bit about me. So I've been doing databases for 20 years now. They haven't changed much. Well, relational databases like you're learning right now haven't changed much. What has changed is now we've got new databases called NoSQL databases or graph-based databases. It's where the data is no longer relational. So you understand what a relational database is? I'll nod, or I'll go,
Please nod.
Please nod. Yeah, so relational database, like, okay, in the real world, we don't really admit that Access is a database, but it is in a little way. Access is actually the first database I worked with. It's very, very cool for just quick little stuff. You've got a department that needs some help doing something. I have an Access database at work that I keep up with all my people, just because it's easy. It's got built-in reporting tools and all this stuff, so it's really easy. But you got tables that have columns and rows. That's relations. And a table's related to another table. When we're designing, we talk about entity relationships, and you said the ERDs, an entity relationship diagram. So the person's related to an address somehow, or the person's related to a class, so stuff like that. If they're students related to a class, and professors related to a class, and so by the inference of the class, the student's related to the professor, and those are relationships. So those are relational databases. for instance, the Oracles, DB2s, the SQL servers, MySQL. Now MySQL is forked to MariaDB, all those different databases are relational databases. Then there's the NoSQL things that some of them are like cache databases. If you understand cache in the web world, where we're caching data, they're key value pair type things where we just throw a bunch of data that we're going to need, and we don't have to worry about, you know, querying them with SQL and stuff like that. It's just, hey, I want to go look up some key and get a value out of it. So that's some of the newer types of databases that are out there. And some people just don't care about some of the things that we care about in relational databases. Like, have y'all talked about ACID? No? Okay. Do y'all cover ACID in this?
I don't
No?
think so.
Okay. So y'all
Possibly
don't
the
get to
next
do
one.
ACID. That's good.
Sorry.
It's not good for you. ACID is just a term of, it talks about what a relational database has to be able to do. The transactions have to be atomic, consistent, blah, 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 blah. The NoSQL databases don't necessarily follow the ACID rule. They follow what's called a base rule usually. And so the data doesn't have to be consistent right away. So if you think about Facebook, they got a gazillion servers around the world running. You put a post on there, somebody in China doesn't have to see that post within a few seconds of you putting it on there. It could take a little while till it makes it over to their servers and stuff. And that's kind of the idea of eventually the data is consistent across the system, but it can lag around. In transactional databases, we usually don't like to do that because they're transactional databases. For instance, when you go to the ATM, do you want it to know that your paycheck got in there or not? Usually because I want to get some money out of it, you know? So, you know, transactional databases like SQL Server, Access, and those follow this ACID rule. So there's rules they have to follow. Anybody that makes one of those databases, the database system has to follow some certain rules. So let's talk about normalization. Do y'all know what normalization is at all? Anything? Anybody? What is normalization? Nothing. Okay, so what do we have in a database? This is an easy one.
Table.
Yeah, but really what do we have in a database? Data. It's all about the data. Usually there's two types of applications out there in my experience. There's data-centric applications and non-data-centric applications. Can you tell me a non-data-centric application? There's one you probably use quite often. It starts with an N and ends with a Flix, and there's this Netflix and chill saying and all these kinds of things, you know. Netflix. That's not necessarily a data-centric application. It's more about you streaming videos. Now, yes, there's data involved. But really, at the end of the day, they're more about you pick something, we can stream it. The ATM. You think that's a data-centric application? Yeah. Because it's all about the data. That's your finances. You don't care what the interface looks like. You want the numbers to be right. So when you go to your bank account, you want to know you got the 20 grand in there. Because I know y'all have that kind of money because y'all are students. Ain't got nothing else to do. So y'all got all that cash in there, and you go in there and you're like, I'm going to take out some. Well, that's data. That's a data-centric application. And the data-centric applications are where relational databases really thrive. So there's some things that you need to do to make things work well. Just like if you're exercising, there's some things that you should do and shouldn't do to help your body in the exercise. Like if I'm exercising, going to McDonald's 3 times a day is not really going to help me. You know, I need to eat right. Well, with databases, if you want to have a data-centric application and you want the data to be right, there's these this term called normalization that I don't even think about anymore, but it's just stuff that we do to make sure we're not going to have problems with the data down the road. Have y'all talked about keys? So when y'all build a table, what kind of keys do you put on it? And what's a primary key? What does that mean, a primary key? So I can uniquely identify a row, okay? So that's cool. So I can uniquely identify a row because I've got a primary key on there. So that means I can always find one row using one primary key, whatever that is, right? Okay. That's a little bit of normalization. That's not exactly, it's kind of covered in normalization, because if I don't have a primary key, do you know what that table's called? It's called a heap. If we don't put a primary key on the table, we call that a heap table, because you're basically just shoveling data in the table and you're just going to get data back out, but I don't know what you're looking for because you don't have any primary keys. So I can have the same thing, I can put the same pile of dirt in there 100 times. There's nothing stopping me, helping me, preventing me. Normalization are rules and techniques to help you get your data right so that you don't have problems later. So for instance, let's look at, and I'm going to cheat, because like I said, like Professor Penrod was like, yeah, you're going to teach normalization. I said, well, I'm going to try to, but I don't remember half of this stuff because I don't call it this stuff. There's this thing called Wikipedia. Have y'all ever seen that? It's great, because I go out to Wikipedia to look up database normalization, and here's all the normal forms. So 1NF, first normal form, second, third, EKNF, which is elementary key normal form, boys cod normal form, fourth normal form. I hit the wrong button. It goes all the way up through, generally there's about 6 of them that we look at. Most folks will do the first 3 normal forms and stop. Because the 4th, 5th, and 6th one get really picky with the data. And there's an idea of there's a concept of being too normalized. Sometimes we'll do what we call denormalize the table, because it's, when you normalize, so let's talk about normalization a little bit in just general terms. So you guys are students. And usually when I'm designing, that means an entity. So, and this is the way I start out. I start out talking about thinking of concepts. You know, I'm going to build a database for a healthcare system or a government system or my own finances or whatever. You know, I sit here and I usually find me a big old whiteboard and start doing this stuff. So students, and you guys have classes. My table, these will turn into tables eventually. My tables always are plural because they hold more than one row. So this is just my little thing, the way I design. All my tables are plural. So I go to students to get a student. I go to classes to get a class, you know, that kind of stuff. If you're doing programming, you know, this would be a collection of student objects, so it's kind of the same thing. So you got students, classes, professors, and then you got some relationships between there. So, you know, students have classes, professors teach classes. So that's kind of a relationship that we're doing between those. But some people, this is the way I always start out. I always have. So you've seen people that are good at, let's say good at sports. So somebody that's really good at basketball. Doesn't really, my son, my youngest, I've got 4 kids, my youngest is 13. And he'll sit there and spin that ball on his finger, and maybe a second before it falls on me. And he's sitting there just slapping that thing, smacking around, and he'll do these tricks behind his back and all this stuff. And I'm like, man, he practices all the time. But I think he's just got a natural knack for that. Well, for me, I, for some reason, have a somewhat natural knack for designing databases. I don't know why. It's a weird thing to have. Because I start out like this, but here's the way some people start. So they'll say students, and they'll just start coming up with some what we call attributes. They turn into columns. So what's an attribute for a student? They'll have names, an ID, so what else? Date of birth. Address, okay. What? GPA, okay. Now, let's just stop there. You ever have more than one address? Yeah, so what happens here is I've got Mark 1, way old. I'm not going to put all of it because it's a long one, but, and I can't spell Natkish. Okay, what is up with that word? There's nothing in there except the first letter and the last letter that actually matches up with the sound that you make when you say that name. What is up with that? So I'm going to say where I spent most of my career, Atlanta, and GPA. Well, right now I have, in my master's program, I have 4 of them. I've only taken 1 class. So I'm doing well. And I'm in my 2nd class, and right now we got our first test score back yesterday, and I made a 95, so I was sweating too. Because he did the test review, and what he said and what I remember putting on the paper was not the same, but he was gracious. So, okay, so I've got this stuff. So, let's add one more thing. Let's put a telephone. So, how many of you have more than one number? Okay, so I might be tempted to go, wow, I can't. So let's say 1, 2, 3, 4, 5 is a number, was that me? I'm sorry, yes, that was me. Sorry. And I might put a comma there and say 6, 7, 8, 9, 10. Now, first normal form is all about this right here. So if you look at the definition of first normal form, which I'm going to read from Wikipedia because I don't have this memorized. Well, I'll read it to you, and then you tell me. A relation is in first normal form if and only if the domain of each attribute contains only atomic values and the value of each attribute contains only a single value from that domain. Did anybody understand that? Me neither.
Our book is nicer about the definition.
Yeah, yes. So, if you don't know this, you probably do, but if you don't, relational database is built on top of set theory. So it's mathematical. There's hardcore mathematics involved in relational database theory. So some of these definitions get very X to Y and Y to Z, then X is to this and all that stuff. Basically what it's saying is this has more than one value. I put more than one thing in there, so it's no longer atomic. Atomic means just, in database when you talk about atomic, you're talking about one thing. An atomic transaction is the whole transaction. This is, first normal form is, this is a no-no. So what would you do with this? Well, I'll tell you what I normally do. I normally create a contacts table, and then this comes out, and I have a type and a value, and I may have other information too, but the type would be, like cell, and here's a number, and home, and here's a number. And then I would link the two. Now, to link the two, I would have to, this is another trick, dependencies. This isn't necessarily normal forms, but when you have, we draw it like this. If I have a table that's dependent upon another table, so this is students, the key, whatever is the key in this one, has to come down to this table. That's just a rule. Don't fight it, just be one with it. Because there's no need to fight it. It has to come down. So if the key is ID, then ID comes down. If the key is name ID, then name ID comes down. Now, I need to add something else to it to make the rows unique here, don't I? Because if I put Mark 1 and Mark 1, look, I'm in there twice. So I need something else. So now that becomes the key. Mark 1 and type, unless I find out that I can have multiples of the same type. And then I'm in trouble because I'm like, oh crap, what do I do now? I don't know. So, but that's a good start right there. Does that make sense? You ready to go to sleep? Me too. All right, so that's first normal form. First normal form, pretty easy. Now let's look at second normal form. Let me look at second normal form. Come on. Second normal form is actually cheat sheet. Second normal form is right here. We've got a problem with second normal form. So second normal form is basically, so let's think about this table right here, students. I need a key. What's the key for that table? Somebody, back in the back of the corner, what's the key for that table? Name. All right. Who else has got a key? ID. Those are both legitimate. So what's going on? I got more than one choice. Do I? Mm-hmm. So second normal form is a functional dependency on part of any candidate key is a violation of second normal form. So I could say name, database address, GPA. I could say ID, database address, GPA. I might say name and date of birth with my address. So I've got a lot of choices there. So second normal form, especially if I do it this way. You can tell I don't put out a whiteboard very often. My birthday's not going to change very often, which is coming up, by the way, if you want to give me something. It's Sunday. But now I live in, but I still have a 4. Now what do I do? Because now address plays in, and is it starting to make sense? I'm getting weird here. I could do ID and some of this stuff and be right. I could do mark and some of this stuff and be right. So usually what happens here is we make another table. Now I don't have the redundancy going on. Because you can you give me some thoughts of why redundancy causes problems for us? So if I go back to, wow, I can't hit Control Z, can I? No Control Z on a whiteboard, what's up with that? So if I go back to address and I've got Atlanta, and I'll just put BC, because I was born that long ago. So, update my GPA. How you gonna do it? We don't do nothing manually. Nothing. We've got computers, they do all the hard work. But so, have y'all worked on SQL yet? Not yet? Okay, so SQL, structured query language. It's what we use when we're talking to databases. So I'm gonna write something, it won't make much sense to you, but
They've done some active queries in Access, so they should.
select star from students. Where? Well, I can say where name equals Mark. Now I'm gonna get 2 rows back. Instead of 1 row. I'm gonna get 2 rows back. Now, I can deal with that, but let's say we get into an application where one person pulls up this row, for some reason they searched and got my Atlanta address, and somebody pulled up this row and picked up my Bossier City address, and then they go to update the record, and this one gets updated to a 3.5, and this one somebody updates to a 3.2. Now the data is inconsistent. Does that make sense? All because I didn't have I had this redundancy. This redundancy causes problems. If you asked the bank for your balance and they came up with 10 balances for you, which one's right? Especially if they're different for some reason. Which one's right? You only have one balance in your checking account at a particular time. But if I don't design my database correctly and you get 10 balances back, and you're building an application to show somebody their balance, which one are you going to show? Which GPA are you going to show me? What's my GPA right now? So I go to the NSU student portal and I want to see my GPA. Which one do I get? Or actually, I go to the LSUS, because that's where I'm going to for my master's, and I ask for my GPA. Which one are they going to give me? Probably the lower one. So, so that's why we worry about normalization, because we're trying to prevent stuff like this. So first normal form, got the contacts out of there. Second normal form, helped me get the addresses out of there. I won't put that back. I like the 4. As long as I've got one, I want to have it. Because it won't last forever, based on past history and all. So third normal form. Third normal form is fun because there's actually a nice little saying that comes along with third normal form. So back in the old days, back when I was in diapers, there was this guy named, what was his first name? I wrote it down. Edgar Codd. And he is one of the fathers of relational databases. So he came up with a lot of this database theory that we use. So there's a nice little saying for the third normal form. And I wrote it down just so I wouldn't get it wrong, didn't I? Every non-key attribute, so if this is the key, every non-key attribute must provide a fact, must say something about the key, the whole key, and nothing but the key, so help me God. So if anybody watches crime dramas like I do, and I watch crime dramas, that's an easy way to remember third normal form. So a way to, right now this is, I'm going to do something just to make it a little more simple. I'm going to make a key column and just put a, in databases, there's some, so in databases there's what we call camps or schools of thought and stuff like this. There's some fun little things that we'll get kind of religious about, like nulls versus not nulls, and surrogate keys versus real keys or logical keys. So the logical key for this could be my name. It's not a good one because there's more than one Mark Summers. If you've probably seen the other one. He did Double Dare in the 90s. He did Unwrapped on the Food Network. I'm not him. I wish, but I'm not. So we're both Mark Summers, but he's a different one. So there's two of us. And maybe he went to school here, and that would be horrible because then the key's broken. And if you've got a primary key constraint, which you always have a primary key constraint, in your table, it won't let you put one of us in there. Luckily, I probably got in there first, and he didn't, because I'm here and he's not. So I'm putting every table I ever create, I put a surrogate key on. It's just the way I do things. Whether I think I need it or not, I just always put it on. It's easy. Doesn't cost anything. It's usually a long or a big int or something. Integers, 2 to the 32nd, big ints, 2 to the 64th. So they're really big numbers. You're probably not going to run out this year. Depending on the type system, we actually cycled through the ints one time on one of the systems I was on. We had tables with millions of rows on them, millions. And one database I worked on, it was about 250 gigabytes for the database, and then the image store was about 5 terabytes. So a lot of data. We couldn't actually back up the image store because by the time it got through backing up, it just had to run constantly because it couldn't keep up. So anyway, so Facebook and places like that, they can't back up. There's just too much data. Google, they can't back up. There's too much data. They have to do redundancy, so if the system goes down, it exists somewhere else. So we put this key here. So Mark refers to the key. Key number 1 is Mark. Key number 1 is ID 1. Key number 1 is date of birth. Date of birth talks about key number 1. Atlanta talks about key number 1. GPA, actually we took address out, so I'll drop that out. GPA talks about key number 1. What if I added school there? Does the 40 talk about the key, or does the 40 talk about the school? It's probably still the key, but we're getting kind of fuzzy at the moment. We're getting kind of fuzzy. Let me see which one they used. Address. If I had a key out here, phone number that I had at that address, is that really a phone number describing the key, or is it describing this right here? Yeah, possibly. If I had here's one. Cell. Because there is no other. I'm an iPhone guy, sorry. I've had one since came out in October of 2000 something, and I got mine in November. So I've had one since the beginning. So I actually do have a Samsung Android thing. I don't call on it, but since I'm taking the Android programming class at LSUS right now, I've got an Android. So if I put the model here, is the model really talking about the key? Or is the model talking about some other piece of, some other attribute? Some other attribute. See, this doesn't really make sense here. For one, model for my home? Nah. But what I'm trying to get to is, as you get progressively up the normalizations, they get harder to see. So when you get into fourth and fifth and sixth, they're getting really picky. Third makes pretty good sense. It's when you've got data that just doesn't really fit. Like for instance, if we had address, if we had ADDR1, ADDR2, city, state, zip. This is really about the rest of this. They're talking, each of these are talking about this whole and not really about the key up here. Does that make sense? So when that starts happening, that's a clue to you that something's wrong. And that's all normalization is. All normalization is a clue that something's not right about your design. The reason that, we've already talked about the reason this would be bad is because my address changes. So if I had my address on this line, and let's just put it up here, let's just say all those fields are there. If my address changes, well, you could update it and put the new address in there. But what did you just lose? You lost something. What did you lose? If I change my address, what did you lose?
The old one?
The old one. So when you call me and say, where's my package? I ordered this from Amazon. Where is it? Well, I shipped it to, I think I shipped it to that one because I lost the old one. So now I don't have this nice table down here with all your addresses and different keys and go, oh, we shipped it to this one. Well, I moved. Well, you didn't tell us. So when it comes back, we'll ship it to you again. See, that's what that's for. Just simply putting it down here gives me that ability. So when you're learning normalization, normalization is techniques to make it easier on you when you get too far down in the project to start changing everything. If my application's in production and I start having this problem, I'm in trouble. Because now I've got to change my table structures. Which means what? Somebody's got to change their code. And so it starts snowballing. Everybody's got to start changing things. Why? Because I missed something. If I had gone through and said, hey, let me just check and make sure I got first, second, and third normal forms. Okay, cool. I'm good. Everything looks good. It would have saved me a whole lot of trouble. So that's why you learn normalization. Now I'm going to show you one thing that we do that has to do with denormalization. So I said earlier that denormalization has to do with the fact that sometimes performance is more important than the structure of the data. Okay? For instance, how many of you know what a log file is? Oh, come on, log file? Okay, so, let's see. Okay. No log files. That's a good example. Dang, you stumped me. Now I gotta come up with a different example. Let's say, let's do this. A list of transactions. y'all all been to a bank or an ATM? At some point in your life, you actually handled money, right? Cool. Everybody got a debit card? Take money out of the ATM? So somewhere in the system, they've got a big old transaction table. And they're going to record a whole lot of information. They're going to record who, what, when, maybe where, all this kind of information. Now, I could, when designing the database, normalize all that information. I could have a who, and I could have wheres, the who's and the wheres, and the whats maybe, and they're all connected somehow with some relationships. At least the who's and the wheres, because I know where my ATMs are and stuff like that. And so whenever a programmer has to deal with it, they've got to deal with all this relational stuff. And if you've done your job with your database, there's database integrity. So you put primary keys, and you might have put some what we call referential constraints, meaning maybe I can't be in this table unless I'm in this table, and I can't be in this table unless I'm in this table. That's called referential integrity. And so when you do things like that, so like if you have parents who have children, I can't have a child unless I have a parent. Last time I checked. So this is dependent upon that. So for me to put a record in the database for a child, I've got to put the parents in first. Because if I try to insert them here, your referential integrity is going to go, and it's going to make me stop, and it's going to give me an ugly error. So I've got to put Holly Summers, my mother, and then I can be in there, because she had a child. Actually, she bought me. I was bald. I'm adopted. I like that. I was bald. So the other three children, my two brothers and sister, they're nothing because they paid for me. They picked me out of a lineup. They really did back then. They took them through and they'd line up the kids. And anyway. So if you do this kind of stuff, then as a developer, I've got to make sure I put it in here first, and that's successful. Then I can put it in here first, and that's successful. But what if I fail going into here? Then things go wrong because I can't put it in here until I get it in here, and it causes a problem. And when you're talking about bank transactions, you don't want to sit there and wait all day for the computer to go, "Ooh, I got to put it in the first table, the second table, the third table," and get all that done. So what we'll do is flatten it. We'll take those tables and we'll flatten it into one table. And we'll consciously make the decision to ignore some of the normal forms because it's faster. It's typically data we're not updating and we're not deleting. We're simply inserting. So transactions, when they go in, now we could possibly go back and void a transaction, so we might do a little bit of updating, but it's not heavily updated. The main thing that we're going to do is insert the transaction every time somebody does one into the table. So this table, a denormalized table, will usually be what we call wide. It'll have a lot of columns. That whole third normal form where, this column doesn't really talk about that column, it should talk about the key. Forget that, it can talk about that column. We'll put it in there because it's easier, it's faster. The whole idea with your ATM transaction is get your money and get out. So they'll do that kind of stuff, and that's denormalization. Normalization, remember, normalization is about getting your data right so you don't have headaches later. But sometimes, all right, there's a law out there that says don't speed. sometimes you're allowed to break the law. So the fire truck, we don't make the fire truck or the ambulance or the police officer follow the speed limit. Why? Because we want them to get there as quickly as possible. But typically, we want most people to follow the speed limit. So most of the time, we'll do the first 3 normal forms. But every once in a while, it'll be more important to get there quickly, and we'll back them off. Make sense? Questions? Should I turn on my cricket sound? No questions? Nothing? Ideas? Thoughts? I hate databases? Anything? Pulse? What?
Would it be the, what if it's the same data, but you don't want, like, you have this data, you have it, normalize it, then you have this data, denormalize it, would that cause some kind of data redundancy?
I don't quite follow you. Can you give me an example?
Like, let's say you have a normalized database, and you have your.
So I got a nice structure here that does its little thing, and this, and this, and this.
You have your who's, your what's, your ones, and your where's. You have all of that, just very nicely designed, and, but you also have a database where you just want to, get your information quickly, and it's not normalized. But you have the same data in both databases. Like, you have marked in both databases.
So you bring up a point that's something we do for, so there's types of systems, if this makes any sense. So so OLTP is what we call an online transaction processing system. So the pharmacy system I worked on, the claims processing system, the ATM financial system that your bank uses, the system that Northwestern uses with all your grades and all that stuff and your classes. Those are online transaction processing systems. There's another flavor called online
Analytical.
processing systems, so data warehouses. That is sort of what you're talking about, but it's not necessarily that we denormalize it. There's a different structure for these than there are for these. These OLTPs are hierarchical, so parent, child, grandchild type relationships. OLAPs come in usually one of 2 flavors, either a star, the center of the star is called a fact, or a snowflake, where it's snowflake schemas have to do with, so in the star, and these are systems like Home Depot has them, a lot of your retail systems, I'm sure Amazon, all those folks have systems like this, but this is your fact. So this is, they get the name from, because we're really boring at naming things sometimes, but it's just a fact about something. So you made a purchase. Well, I bought that Diet Coke. So here's Diet Coke. Mark. There's these things called dimensions. And that's these points out here. So a dimension of a fact is time. So I bought my Diet Coke at a time. Well, there's more than one time. So time, there can be different values and stuff. So it's either a star schema or a snowflake schema. So it's not that we denormalize the data, we structure the data differently. So what you were kind of where you were going is there's sometimes I need this kind of system to do what I want to do, and sometimes I need this one. This one, everything can be repeated over and over again. Mark, Diet Coke, because I was thirsty today at 14:05. Because that's the only piece that might be changing. And so you get a lot of redundant data, but what that does is make data analytic packages work real well. I can go through and do all kinds of cool trends and all this kind of stuff, and do surge pricing, and all these things that they come up with. I can give you hints on what movies you like. Am I making any sense here? You ever seen that? You go into Netflix and we got some suggestions for you. They're mining your data. They're keeping track of everything you've done. And they're going, well, if he likes this one, maybe you'll like this one. And if he likes that one, maybe you'll like this one. So they can go through, probably not this, probably a system that's structured more like this. Not necessarily, but probably more like this to come up with, here's some suggestions for you. Now they might actually be using some NoSQL stuff and some of those graph databases, but that's kind of the idea. And that's cool stuff. This is fun. Databases get big because there is a lot more redundancy. Databases get really big really fast. And you deal with it differently. There's things called cubes and all this stuff that you get into, and some heavy statistics and all that stuff. So I hope you like math, because it can get in the weeds quick. But yeah. What other questions? Nothing.
Do you have any database in the real world questions in general?
Yeah.
Or what CSRA is
Or
about?
even what it's like working with databases, or what's the scariest you've ever been with a database, or
The worst day you've ever had?
Yeah. Oh crap, we deleted the customer's database day. We're down for 3 days and business ain't working and the CEO is about to kill you days. Yes, ma'am.
Is it like difficult working with like databases and being responsible for all of the information and that kind of stuff?
I wouldn't call it difficult. It's no more difficult than driving a car. You have responsibilities not to kill anybody when you're driving a car. You know, you don't run up on the sidewalk and mow people down. It's, you know, it's really, once you learn how to do it, it's not bad. Now, I will say that I don't like, so this is a term we use with a lot of folks in my genre called DBA, Database Administrator. And then I'm what they call a data architect. This guy takes this, and I use guy in the gender neutral sense of the term. This guy is doing the, make sure it's running, we're backing it up, it's performing, doing all that stuff. This is the person that designs them. This is the part I like doing. I never cared for this that much. Some people like it. And there's a lot of people that do that. They like the, you know, keep it running and, oh my goodness, it crashed, and all the adrenaline and all that stuff. I just like designing things. I like building things. So it's kind of the two flavors. And you'll also see, another term you'll see is database developer. And that's usually someone who hasn't quite gotten here yet. So they're newer in their career or younger. So they're the ones that'll, okay, I come up with the pretty ERD, now you go build it. You know, kind of thing. Or I'll do the hard pieces and you do these pieces, or I'm doing some really big stored procedures and they're building the tables, you know, all that kind of stuff. I've done a lot of integration work, so in database land, there's a term called ETL, extract, transform, load. So we extract data from somewhere, transform it into something that will fit into the system we're going to, and load it. So a lot of times, this happens right here. we're taking data out of the OLTP system, so out of your bank system, and putting it into a data warehouse, and then looking at trends, financial analysis, what other products can we sell you, you know, all that kind of stuff. But yeah, I mean, yeah, there's days that it can be horrible, just like anything else. Just like driving, you can drive through a storm, it's no fun, but you know, usually the storm ends and you make it through, so.
And then there's the superhero days too, where you.
There are the
yeah.
superhero days where you save the day, and everybody thinks you're great.
People like the data people.
Yeah.
They do.
Yeah. Because really, if you think about it, when we talk about data-centric apps, it's all about the data. If this part isn't right, then nothing's right. I don't care what you do. If we don't get this part right, it's like the foundation of your house. Or, it's like your feet. You stand on your feet. If your feet aren't right, you're going to have trouble standing. So get your feet right. This is the bottom of the pyramid, you know? If this isn't right, then there's a whole lot of things that are going to go wrong. Now, that's not to say that we don't make mistakes, because we do. We'll get in there and think that this was related to this, when we find out in the real world, well, it's kind of related to this, and it's kind of also related to this, but we missed this, so we got to go back and, okay, we do some fixing. We add some stuff and, you know, do what we need to do. So, you know, we make mistakes all the time. You make a mistake, you just go ahead and fix it. If you catch your mistakes earlier, though, it's a lot less expensive.
What's the worst mistake you've ever made?
Worst mistake I've ever made. Worst mistake I've ever made. I've made mistakes in the claims processing system that cost upwards of $1 million for the customers over the time that the mistake was out there. But I never considered that a huge mistake. It was just a mistake. I do know of instances where, well, for me, I don't know. I mean, now the one that probably scared me the most was I did an update without a where clause one day, but luckily I was in our test system.